Hello, this isn't the usual type of content that I put out, just so you know. So if you're interested in that usual kind of content, this might not be the video for you. This is more about home energy generation through microgeneration and a specific piece of software that I've written that controls the hardware that I've got. So I'm describing this in this video. This is the Wallbox Quasar controller that I've written. The URL for that is as stated. It's open source software. It's on GitHub. And let's get into it. So in summary, the system that I've written, it controls the Wallbox Quasar using Modbus connections over the internet. Over the internet. It doesn't need to connect to the internet. It obviously needs to have access to the network. It could in principle work over the internet, but that's not how it's designed to work. It can set a charging rate from 3 to 32 amps, a discharging rate from 3 to 32 amps, or a quiescent state, and it monitors the grid power. That's the power coming in from or going out to the national grid, and has the capability to monitor another system's power if that's desired. It's not needed, but it will do that. And it can operate in multiple ways. It can do constant charge at a given rate that you specify, which would typically be the fastest rate that is supported, up to 97% state of charge, which is the highest state of charge that the Wallbox will charge to when connected to the Nissan Leaf, probably the EV200 as well. I'm not sure about that. I think the limit is 97%. In normal circumstances. In fault circumstances, I have seen it charge fully, but it can't do that under normal circumstances. It can do constant discharge. That's useful if you want to sell power. If you want to sell energy to the grid, when it's advantageous to do so, you might want to do that. It'll do voltage to home, which is basically load following in terms of discharge. So it can power the home through the vehicle's battery by matching the draw that the home is making. So what it's looking to do there is to minimize the use of the grid. And there's also S to V, which is if you're generating power locally, that will usually be from solar. It can take that into the car and it'll do the same thing. It'll basically charge at the right level of current so that the power isn't exported to the grid. Or not much of it is anyway. It can do both of those things at the same time, so that means it can charge, it can switch to discharging, it can switch to charging, it can adjust its level so that the grid power is basically around zero. Sometimes the Wallbox gets into a bit of an error state and it can't communicate with Modbus anymore. If it gets into that state, it is possible to reset it through software, but the way that works is using Wallbox's own cloud API, so an internet connection is required for that functionality to work. You can set lower and upper limits on the current level that you're using in software. You can hold the quiescent state, the dormant state, for 10 minutes so that the vehicle can be disconnected, and the reason you might want to do that is simply you set that going, you unplug your vehicle, you go somewhere, you come back, you plug it back in, and more than 10 minutes have usually passed by this time, and it'll go straight back into its normal state of charging, discharging, V2H, S2V, whatever it's doing. When the vehicle is initially plugged in, the state of charge isn't known, and it won't be known until charging or discharging happens. So the software can charge at a low rate until the state of charge is determined, and then it will switch to its normal operating mode, because some of what it will do depends on the state of charge. And it also has basic logging capabilities, so log grid power, channel 2 power, whatever that happens to be. I have been monitoring solar for the most part, but I've recently switched to monitoring just the power taken by the Wallbox so that I can see what's going on. It also logs state of charge and the control state, and at the moment it's also logging power factor. I don't think that's very useful, but I have included it for now. I'll probably get rid of that because, as I say, I don't think it's very useful. What you need a Wallbox Quasar. You need a computer that can run Python. Python is a programming language with a suite of libraries. It's quite easy to get to grips with, quite easy to understand. And it had available a Modbus library that worked, which was very attractive for obvious reasons, and a couple of other libraries that I've also used. You can use it on all of the conventional operating systems. I'm sorry my video's hunting in and out. I'm sorry if that's a bit distracting. There's this camera's got a bit of artificial intelligence in it, and it doesn't seem to be very intelligent because I'm not actually moving forward or backwards. Let me see if I can just turn that off a second. Right, hopefully it should stay put now. Yeah, so you can use it with Windows, you can use it with Mac OS, you can use it with Linux. You can probably use it with other systems that can run Python. I'm familiar with Windows, Mac OS and Linux. The hardware you need, it's not very much. You can get away with the Raspberry Pi. Probably an ESP32 would do everything bar logging. You also need a Shelly EM, and that will have one or two current transformer clamps to do the power monitoring. So this is the device that detects whether there's energy coming into or going out of your house into the national grid. So if I follow that link, if I click on that, is that going to take me there? Yes, it will. That's what it looks like, and we'll talk more about that later. Let me go back to the slide. Right. You're going to need a box to put it in. You're going to need a 13 amp plug-in cable. You're going to need to know very basic electrical skills. If you know how to wire a plug and you know not to touch 230 volt live terminals and all that sort of thing, then you're probably good for this. You don't need to be an electrician. Ideally, you need to know what a text editor is, and you need some very basic programming skills. I'm going to talk you through the software during this presentation. Sorry about the quality of this or the lack thereof, but this is basically the schematic diagram of the system. So you've got the Shelly EM, you've got a couple of CT clamps, current transformer clamps. You only need one, and I'm going to show you a picture in a minute showing you my setup, but you place one clamp around the live or the neutral grid wire. So that's I think they call them tails. That's the tail that's going into your house. It's probably a pretty thick cable. It's between the meter and the rest of your setup, basically. If you're using the second channel, you can put that wherever you like. It might typically be your solar power generator, or it might be the tail going to the wall box. You also have to wire the live and neutral terminals to 13 amp plug. You might want to put a 3 amp fuse in it. That should be sufficient for this device. You don't need to wire anything to the O pin. That is not used in this product. It's not used by me, but it can turn on and off a device that can draw up to 2 amps by the control of a program, should you have any requirements in that way. I don't. And this is my system, so basically I've got it plugged in here. This was a spare cable. It's going into a box here. I actually just 3D printed a box. It's not a very good one, but it does the job. It keeps things safe. So inside there you've got one of those Shelly EMs that I showed you the picture of earlier, and coming out of it I have 2 of these CT clamps. They're both 120 amp. This one is monitoring the grid power, so that's the power coming in and out of the home from the national grid. This one is monitoring the wall box power at the moment. I think it was originally on this one, which is for my solar generation. So how to configure this? Well, when you've got your Shelly EM, you're going to want it to connect through your home Wi-Fi network. Shelly themselves have the documentation that allow you to set that up. You're going to need to address it through its IP address or its local name, whatever that happens to be. And it's going to be something along the lines of Shelly EM dash with a bunch of hexadecimal digits. After that, Ultra Hub happens to be the domain of my local network. I have a Vodafone fiber to the home network. That might be .home, it might be .broadband. It's going to be something along those lines. If you can't find out what it is, you can go to your Wi-Fi setup and see what devices are connected. or you can find its IP address, but that might change depending on how you've got your DHCP set up. I don't want to go into too much detail about that because that's not the purpose of this video, but there's plenty of videos out there that explain DHCP, Dynamic Host Configuration Protocol, and explain how an IP address is assigned to a device and how that could change. So you might find it more reliable to use the name rather than the IP address, and that's what I do. But you can use whatever you want to do, obviously. My Python software uses its REST API, and it polls the Shelly EM once a second to find out what the grid power is, what the other channel's power is, what the voltage is, and all that sort of stuff. The Shelly EM does support MQTT. I haven't done anything with that. How to install the control software and its dependencies. So there's many ways to do this. Now I'm going to assume that you're not a developer. If you are a developer, you'll probably use Git to do it and clone the repo, but I'm assuming that you're not. So you would go to this URL, there's a green code box on there, and you download a zip of the repository from there. So if I click on that, there's the code box. I can click on that, and then I can click on download zip. Let me make that full screen again. There we are. You're going to need to install Python 3, not Python 2. Python 2 is quite old now. Make sure you get Python 3. This code will not work with Python 2. So you can get that. I mean, you could Google Python download. You also need the package manager, which is pip. And that, if you're installing on Windows or something like that, it'll probably be installed automatically. But if not, you can go to this URL to find out how to install it. And then you need to install a few libraries. So you're going to need to start your terminal. So that's kind of like what would have been a DOS command line in the old days. It's no longer really DOS. It might be PowerShell on Windows, Z Shell on macOS, and it could be typically Bash on Linux. But it doesn't really matter what it is. You just install these libraries. There might be... You might have to find the path at which pip is installed. If that's a problem for you and you need some help from me, just ask me in the comments. I'll see what I can do. So you've downloaded your archive of software from GitHub, which is the software that I've written. You can unzip it. And then you need to edit. There's a configuration.py file. You'll need to use a text editor for that. Something like Visual Studio Code would be ideal, but you can't use a word processor. I think most people would probably understand what a text editor is as opposed to a word processor, but if you do use a word processor, it's not going to work. You need the IP address or DNS name of your wallbox, and it's going to be something like wb1234556.ultrahub. Ultrahub again is the domain of your local devices. This is going to be your serial number, probably. you already determined the IP address or DNS name of the Shelly EM the last time for the last slide. And if you want to have the system restart the Wallbox if Modbus fails, then you'll need the username and password you used to log into the Wallbox app, which is the app you would use on your Android phone or iPhone. And you also need the serial number of the Wallbox unit, and you put all of that information in the configuration.py file. I've said here you can adapt scheduler.py as desired and run it using the command python3 scheduler.py within the terminal. I've just changed the name of that to flux.py. Now you could copy that, you could edit it as it is, you could use it as it is if it's useful to you, and I'll describe that later in this video. In terms of licensing, GNU GPL v3. Now that's basically because if someone takes this and makes it better and wants to make a product out of it, I don't have a problem with that, but I would like them to share their code back to the community. So that's why I went with that. However, at this time of writing, I'm the only person who's contributed to the software, and I could be persuaded to change that license if it came to it. What have I got? I've got a Quasar Wallbox. Mine is limited to 16 amps because of the permission that I have. I've got a Nissan Leaf E Plus, which is 59 kilowatt hour capacity battery. I also have solar generation, and that can produce up to 3.6 kilowatts of power. Often, I've seen it generate up to 3.53 kilowatts. The panels connected to it go a fair bit higher than that, but of course the sun is very rarely in the right place that all of that energy can be captured, and this is the normal situation. You have an inverter for your solar system that is not capable of using all of the energy that it's provided with. And at present, I'm using the Octopus Flux and Flux Outgoing because they seem to work for me. They're not entirely working for me, but that's discussion for another day. So what does it do? Well, it's very reliable. If there's a problem, it does do that reset, and there's only one time when that reset has failed. So Modbus can stop working. That seems to be a problem with the Wallbox itself, but then it's still possible to reset it using the cloud system. Obviously, as I said, the internet has to be connected for that to work. It responds pretty quickly to changes in supply and demand levels. I'll demonstrate that later. Obviously uses commercial off-the-shelf components, as I've said. Oh, just one thing I'd like to mention as well. If you are going to go with a Shelly EM, I recommend not bothering with their 50 amp CT clamps. I originally bought a 120 amp and a 50 amp one because I thought that's all I would need. Now, from an electrical perspective, that's correct. But from a physical perspective, the 50 amp one won't go around the tree trunks that I've got in, those big cables that you saw in the picture. So I had to buy another 120 amp one. It's been designed in a modular way, so excuse me a minute. If you've got different hardware for your power monitoring, you can write a new module just for the power monitor. And also, if there was a different bidirectional charger, which I'm sure in the future there will be, you can write a module to control that. So I've abstracted out interfaces like a hardware abstraction layer, basically. The Wallbox driver that I've written is aware of how quickly it can change the amount of current that it wants the Wallbox to take, so it can deal with that. Now, there's a lot of room for improvement with it. This is kind of like, if you can imagine, I think there's people that there's this kind of meme thing, isn't there, where you go to a car mechanic, you take your car to a car mechanic, and it's going to come back beautiful, but the car that the car mechanic drives is a bit of a bucket of bolts. It just works, but that's all it. And I'm kind of that type of person, really. So there really isn't a user interface that I've designed. I'm not good at doing that. So basically, this uses a text-based interface. I will show you that, but it really needs someone to design a user interface for it, which might end up being me. I don't know yet, but who knows. I have designed user interfaces. It's just not something I'm very good at. The driver I've written works well for Octopus Flux and Flux Outgoing, but it wouldn't work well for anything else. And I'm going to talk through how one could be designed for a fixed time-based tariff, which is what Octopus Flux and Flux Outgoing is. If you're doing anything with Agile or anything like that, then there's going to be some requirement to do something a little bit different to cope with that. So I'm also at the point where I want to find out exactly what the charging and discharging efficiency is. I think it's around 78% if you're charging and discharging at 16 amps. That's for a round trip. So if you charge at 16 amps and then you discharge at 16 amps, you'll get 78% of your power back, your energy back. Maybe it's an application for machine learning, but it's probably overkill. I did do a course on that, so that is something that I could look into if people want me to. So as I've said, you need to have the basic knowledge of programming to use this. It needs... I think what I mean by I think it needs a REST API is I think the program that I've written basically needs to be a backend that monitors the Wallbox, it monitors the Shelly, and it tells the Wallbox what to do, but a user interface that someone's designed tells that system what to do when it wants to go into full discharge, when it wants to go into full charge, when it wants to do load following, and all that sort of thing. Logging could really be improved. The logging at the moment is just to a flat text file. It is fairly easily parsable with a regular expression, but it's not good. There's some bugs in it. System synchronous. If there's a problem with the Modbus request or a problem talking to the shell EM, then the other system will stop working for a while because they're going round in a loop, and it says, basically it's going, okay Shelly, what's the power? Shelly responds, okay Wallbox, I want you to do this. Wallbox responds, and it's going to do the same thing the next second and the next second. But if that process is held up at any point, then it stops the whole cycle from occurring. And the timeouts need a little bit of tweaking, and they need to use absolute times rather than number of seconds. So pretty easy bugs to fix. I just haven't fixed them yet. If you're going to install it yourself, you need to consider what operating system you're going to run it on. Now, if you're a Windows or a Mac OS user, then you'll probably want to use that, at least to start with and to set things up. But there are some caveats. You may be a Linux expert, in which case that is my recommendation and that is what I use. But if you use Windows Home or Windows Pro, they want to do updates from time to time. I'm sure you're fully aware of that. Sometimes they reboot without any call for a reboot. They might tell you they're going to do this. In my experience, they don't always. So I wouldn't recommend that. Windows Server is probably different. I imagine that won't reboot unless you tell it to. macOS, I think that's probably a pretty good bet if you want to use that. But then you might be tying up a Mac to do it. Linux is a free operating system. It's very robust. I currently use Ubuntu on the system that I have that is exercising this control. It never reboots automatically in my experience. It really doesn't hold your hand as much as Windows and Mac OS do, but it really isn't hard to understand. Ubuntu has quite a decent user interface. If you're going to buy some hardware for this, you've got some options. Tinkerers might like to get a Raspberry Pi. You might want to buy a case. You don't need to necessarily. It's perfectly safe to run a Raspberry Pi bare because it's all low voltage, and this is all low voltage stuff on this side of things. Obviously, you'd need to buy a micro SD card. You might need to buy a power supply and all that sort of stuff. I mean, if you're gonna go that way, then you probably know that this is a project that you'd like to do. You want to get your teeth into it. You want to have, maybe you want to do some learning and all that, and I'm all for that. Or maybe you have a Raspberry Pi lying around and that will work fine as well. But it's not the quickest way to get to your working system. I've got a Pi 400, which is basically a Raspberry Pi that's already in a case with a keyboard and a mouse. And it draws 4 watts when it's in its quiescent state. Never draws much more than that, so it really is good for low power. If you want something dedicated, that's not something you have to put together yourself, you could look. I mean, I've called it mini PC here, but I think some people call them NUCs. These are little computers, kind of designed to work as routers or firewalls, that sort of thing. They're designed for small applications to run them. Basically, low power, limited servers. So an Intel N100 or N305, you're probably talking about 150 to £200 for that. It might include a Windows Pro license. You might not want to use that license, or you might want to. It's probably going to come with it. And they draw around 4 watts. I believe I don't have one. What I do have is a Tricky S5, and I use that for business purposes as well as things like this. Now, if it's running Linux, it draws 4 watts in its quiescent state. It's pretty powerful. A Ryzen 5700U was designed for laptops. It's got a maximum TDP of 15 watts, I believe. So it's really designed for these low power applications. When it's got an onboard fan, very rarely comes on. It's more powerful than is needed for this, but if you want to run other things, maybe you want to run a home server that does some transcoding of video, all that sort of stuff, then that might be a way you might want to go. You can run with hardware you already have, but you should consider that this is not a system that you tell it at 2 o'clock, I want you to stop charging so that I can disconnect the car and visit the dentist. It doesn't work like that. You could certainly implement a system that works like that and use the underlying technologies provided here, but this one is much more of a rough and ready. You have to tell the system by connecting to it, stopping the app from running, and run it again with a command line switch to tell it that you want to pause for 10 minutes so that you can go and unplug the car, do your stuff, and when you come back you plug it back in and off to go again. If you use a system that doesn't have a monitor or keyboard connected to it, a headless system, then you're going to need to connect to that. You're going to need to remote into it. You might need to use Microsoft's Remote Desktop or whatever it's called. You might need to use SSH if it's a Linux box. So it might be better to consider using something like what I use, which is an old laptop, because that's got a keyboard connected to it all the time. It's got a screen connected to it all the time. The downside is it's going to take a little more power, and it'll tie up that hardware. I just have lots of computer hardware just through being a software developer for all of my working life. So what I have, as I said, runs on a laptop. The laptop used to have Windows on it. Now it's got Ubuntu 2204.4 LTS installed on it. LTS means long-term support. I don't recommend non-long-term support options because they're only supported for 9 months, whereas a long-term support version of the operating system is supported for 5 years. I tried to capture the screen with OBS, and I couldn't. So what I've done instead, I did connect to it from another machine with a terminal, so that was with SSH. It's not important that it was with SSH. What is important is it's going to show you how it works. This particular laptop, it draws 14 watts from the wall when the screen's on and 11 watts when the screen is inactive. So it's quite a bit more than the standalone machines. It's not a huge amount of power. And as I said, it's pretty easy to disconnect the car if I need to. It's really an overkill machine for the purpose, but it's a development machine. Right, I've come to the end of my slides, so I'm going to move over now to 2 videos that I've taken of what you see when it's running. Now, this here we show that there was an error connecting to the Wallbox, and I think if there are 10 of those in a row, then it will trigger the automatic reset. I don't have that on video. What I want to show you in particular, though, now I'm going to pause it a second. The number after G is the grid draw in watts. So that's I can't remember. I think negative means we're exporting and positive means we're importing. I could be wrong about that. No, I don't think I am. We're currently logging the power factor as well, which is reported by the Shelly. What's after E is the amount of power drawn by the Wallbox. And I've only just started monitoring that, as I said. And the power factor is also shown. The voltage that it's seeing is shown. Mine's pretty high, but the 230 volts is a nominal amount. It can be quite a bit higher and quite a bit lower than that, and still within acceptable tolerances of the range. I brackets EVSE is the current that the Wallbox is being set to use. So it'll be positive if it's charging and negative if it's discharging. It might not be at that state at this time, and desired shows what we want it to be and what it might change to when the next opportunity comes to do that. Now I'll carry on playing, because what you see here was me turning on the kettle. So the kettle draws 10 amps. Solar was exporting a little bit of power, so the system's computed that the ideal draw from the battery is 9 amps. And it takes about 22 seconds for the Wallbox to start up. And once it's kicked in, here you can see that the grid power is maintaining, it's less than half of this value, and if it ever exceeded half of that value, it might be time for that figure to change. Let's see how this goes. At some point the kettle will turn itself off, but we may also find that the situation happens where it's going to want to change the amount of charge taken by about an amp. How long is this video? It's quite a long one. Let me see if I can just speed things up a bit. Okay, so now what's happened here? That was just an error. I'm just gonna quickly move forward. So the kettle turned off. We're gonna stop exporting from, we're gonna stop discharging from the battery and powering the home, and that's what it's doing here. Where it says ignore, that means the state of the EVSE can't be changed for that number of seconds, basically. So what's interesting, that's basically we got a little bit of a bug here. Once a minute, there's a piece of software that within the scheduler that decides whether we want to be load following or exporting or importing or whatever we want to do. It's not been a great day for generation of solar, but I do remember at some point we did get some generation, and here it is. So yeah, so there's enough generation here for it to be worth turning the car on, turning the car charger on to draw 3 amps. And that's what's happened here. So it takes 22 seconds before it will start, and it's starting, and you see that the power draw from the grid, we're still exporting a little bit. You can see that's going up, and I expect very soon, yeah, there we are. The software has decided now at this point that it's better to take 4 amps rather than 3 amps. Now, it briefly went to a desired of 5. That's because it takes a little bit of time for the wallbox to respond. And we can see that the wallbox is actually taking around 1000 watts here. At 4 amps, 249 volts, that's about right. Is there anything else of interest in this one? I think it maintained at 4 amps for a while. Now then, the grid was powering the charging sufficiently that it went back down to 3 amps. So that all works quite well. And then at this point, the clouds may have come over, and the decision was made to stop the system from charging. So the wallbox went back into its quiescent state. Wallbox draws about 14 watts in its quiescent state, by the way, after the fans gone off, or at least mine does. And I don't think anything else interesting happened during the course of this video. There we are. Okay, so the second video I've got shows what happens close to 4 o'clock. So the time is 3:55. Oh, one thing I didn't say is this system uses local time. So you don't have to worry about any change between GMT and BST or any other time zone daylight saving time that might apply. It just deals with it for you. So we've got at the moment the car is being charged with 3 amps of power. That's probably quite inefficient, actually, but that's something I'm going to look into. It might be desirable to limit it. I know with the standard controls you can only set a minimum of 6 amps. Right, we're going to just go through fairly quickly over to 59 minutes past the hour, and now you'll see what happens when we get to 1600 hours. At this point, it's good to export power. So that's what we do. We change to exporting 16 amps, and that's what the minus 16 desired is for. And once we get past this ignore stage, here we are. We're now seeing from the wall box, we're seeing 3.6 kilowatts roughly. And because I've got a bit of solar, what we're sending to the grid is actually a little bit more than that. To start this, I used the command line option, and that command line was Python 3 space flux.py, and if I want it to pause for the 10 minutes so that I can disconnect, I'll put in space -p for pause. There is some help that you can call up. If you put in -h or -?, it gives you a little bit of help and then it terminates. So the next thing I'm going to do, the last thing today, is just take you through configuration. I'll show you the configuration file. So here you'd edit with a text editor. As I said earlier on, you change that to be the URL that you use to access your wallbox. You can, FQDN is the domain name, or you can use the IP address. IP address might look something like that. It's probably 192.168. something, because that's the standard. So you need the system needs to know how to get to the wallbox, and the system needs to know how to get to the Shelly, and that's how those are done. And for automatic restarts, you set your username, your password, and the serial number of your Wallbox Quasar in those places. You have to configure that for yourself. Obviously, I can't do that for you because I don't know your system. And the other thing I'm going to do is just talk you through my program. This is actually the program that I run. So what we do, we've got it'll recognize command line arguments. As I said, -p to pause for 10 minutes, -h or -help or -? For printing a help message, or you just don't use a parameter, and it'll then just go straight in and start controlling your wallbox for you. This bit just sets up the various systems. So Wallbox Quasar is the system that controls the Wallbox Quasar. Power Monitor Shelly is the system that gets the power draw from the Shelly, and EVSE controller is a system. It's kind of decoupled, but not completely. It's got basically the stuff inside it that runs in a separate thread, if you know what that is. But basically it does the power monitoring and the EVSE controlling. So it is basically the guts of the system, and it's interacted with this simple script. So while true, so this executes, and then it executes again, and then it executes again. It keeps executing. It's an infinite loop. we get the current time. If we're waiting 10 minutes, then we're going to say that we're waiting for 10 minutes. We're going to make sure that the controller is set into the dormant control state. So time.time gives you the current time, and pause state is set up here if you ask for it. So pause state, there it gets the current time and it adds 600 seconds to it. So it's time in seconds. I think it's since January the 1st, 1970, but that's not really all that important. What's important is it just increases once per second. Here, if the battery charge level is reported as -1, that means we don't know what that level is. So we set a specific, this particular setting says do load following, but have a minimum and a maximum current of 3 amps, which basically means always charge at 3 amps. It will soon get a valid battery charge level after doing that. It's a few seconds. Then if the time is between 1600 and 1900 hours, between 4 and 7 p.m., then we go into this section. So if the battery charge level is less than 10%, we don't want to draw too much power from the battery because it's already quite depleted, but I've still got it set to draw at least 3 amps. So to feed the grid with at least 3 amps and up to 16 amps. 16 amps is just the limit that I have in my system, as I said. So if you've got an what's the word for it? If you've got an unrestricted system, not derated, then you might set that to -32. If the state of charge is not 10% or lower, so if it's higher than 10%, then we set it to full discharge, which will discharge at the most rapid state. Otherwise, if the charge level is under 30%, I want it to charge the car fully until it gets there. And, you know, it could be any other time. That's what this rule says. Also, if it's between 2 a.m. and 5 a.m., I want it to grab as much power as it can, because that's when it's cheap to import power. That's when Octopus wants you to take power. Octopus wants you to export power during 4 p.m. and 7 p.m. It wants you to import power between 2 a.m. and 5 a.m. and with the tariff that I've got, it will pay you to do that. It's not an awful lot of money, but it will pay you something. Now I've got some specific rules that are going on here, so I'm gonna talk about these, but basically we've got a kind of ramping up thing going on. So between 5 o'clock in the morning and 1 o'clock in the afternoon, if the charge level is above 72% state of charge, I'm happy for the Nissan Leaf to supply my house, or to take energy from my solar panels, because I've worked out that in both cases that's optimal. And also I can't use all of the energy from my solar panels. If the state of charge has got to 97%, then and the clouds come over and I want to run the kettle, that would be a good time for the Wallbox to start sending some power into the home to power that, because it's cheaper than getting energy from the grid at that point. But if it's below 72% at that point, then really I'm just looking to grab any solar power that I'm generating and put that into the battery. But I'm not looking to power the house, because it's, in this case, it's better to hold on to that power until it gets to 4 o'clock and sell it then. Now, it might be that 72% is not the right level to set this at, but you've got a bit of a trade-off going on. You can have that figure a bit lower, but then maybe also you need to go out on a long drive all of a sudden, and you won't necessarily have the power there. So I like to keep a decent amount of charge in the battery, around 75% or so. I like it to be around there. It can go up as far as 97%, but then it's gonna sell off a lot of that power between 4 p.m. and 7 p.m. for me. But this 72% figure, it basically goes up. Now, if it gets to 1 o'clock and I haven't got 53% in the battery, I just want it to go into full charge state, because we'll be selling energy at 4, but we haven't got a lot of energy to provide the grid with, so let's get the full charge. Otherwise, if we're in 90% territory, we're going to do the bi-directional thing, or we'll do a follow charge, which is like what I said happens between 5 o'clock and 1 p.m. At 2 p.m, if the state of charge is not reached 58%, we want to do full charge. Otherwise, you do the same as before. And at 3 p.m, that needs to be at 63%. So once it gets to 63%, fine. If I discharge from that point, I think it goes down to 41% after the 4 p.m. to 7 p.m. thing. So if it's not between 2 a.m. and 7 p.m, it'll run this rule. So basically that's just going to charge it up to 50% again if it's not yet there. If it is there, correction, it's not going to do that. It's if there happens to be solar generation after 7 p.m, sufficient to do so, which I don't think there ever is in my system, it would do a follow charge. So it won't come on if I turn my kettle on, but it will come on if there's enough solar to power it. Otherwise, if it's greater than 50%, it's going to do the bidirectional charge. This statement is there to get this to run once per minute at the start of every minute. So it'll run through these checks once a minute at the start of every minute. I think that's it for this. I hope that was fairly easy to understand. If you have any questions, feel free to, well, you probably got to me from Discord. Reach out to me either on Discord or in the comments here. If you're on Discord, reach out to me on Discord. This isn't about elevating my YouTube presence. And I think that's it for now. So, yeah, that's it. Thank you very much, and hopefully this has been helpful.